So for this video, we're going to analyze multiple linear regression, more specifically dummy and interaction variable models, as well as quadratic models. So let's go ahead and run library stat cal poly package. Okay, and so we can copy and paste this code, right? This code that allows us to actually run a linear model, LM, and I'm just going to name this model DVM, and my response variable is always on the left hand side of my tilde. Okay, so this response variable is miles per gallon. I have a quantitative DISP, quantitative variable, which is DISP, and the way we can even, just to make sure that we know it's quantitative, just for just so that we can just practice remembering this, is if you do str of empty cars, that allows you to see what kind of variable that you're dealing with. And when it comes to DISP, that is numerical, so that is quantitative. In gears, okay, gear is a factor with 3 levels, okay, and that's going to be our categorical variable. And so we can automatically know that, you have to apply, you supply some data set, and that's what we did here, empty cars data. So when I run this, it stores, and then when I do summary, we're able to get the regression coefficient for our model, okay? And we're also able to get the standard error or standard deviation of residuals, and our adjusted R squared, our F statistic, and our P value. Okay, so nothing really crazy new there. Okay, so now what if we wanted to run an interaction variable model? Okay, an interaction variable model. So what that looks like is, the only thing that's different is that instead of using plus for the dummy variable model, you use a time. That's all you have to do. That's the only thing that's different. It's just you use this multiplication sign. Okay, and so when I do that for the interaction variable model, now I'm able to have the differing slopes, the differing y-intercepts, and the actual just other traditional quantitative variable. Okay, so last but not least, what I'm going to do is run a quadratic model. Okay, so you're not going to have to square each term, but I'll provide the actual square term for you, like I do in this example, is that I'm squaring displacement, and I'm also adding it to displacement. Okay, so displacement plus displacement squared are going to be my explanatory variables. Okay, empty cars is my data set, miles per gallon is still my response variable, and I'm just naming it model quad, and linear model is the function that I'm using. Okay, so then I run model quad, and then I do the summary of it, and I'm able to get my coefficients, my regression coefficients for displacement squared, displacement, and my y-intercept, my p-values, my standard deviation of my residuals, my adjusted R squared, and my F statistic, as well as my corresponding p-value. Okay, so have fun, and hopefully this helps on your lab.